You know that feeling, right? You're staring at a spreadsheet just packed with numbers, and you're thinking, now what? If that's you, you are in the right place. We're going to cut right through all that confusion and give you a super clear 5-step guide for picking the right statistical tools. The goal, to make sure your data analysis isn't just accurate, but really, really powerful. Seriously, it's a feeling we've all had. You did all the hard work gathering the information, but then turning that raw data into something that actually means something, well, that can feel like a huge leap. But the good news is, there's a roadmap for that.
And here it is. We're going to break this whole thing down into 5 simple, manageable steps. First, we'll define your question. Then, we'll figure out your data type. After that, we check the data itself. Then, the big one, select the right test. And finally, we'll talk about picking your software. This is our game plan to get from confused to totally clear.
Okay, let's dive in. Step 1 is defining your question. And honestly, this is probably the most critical step of them all. Everything, and I mean everything, flows from here.
Think of this question as your compass. It's going to guide every single decision you make from this point forward. Are you trying to, say, compare 2 different groups? Or are you looking for a relationship between 2 different factors? The more specific you can be right now, the easier the rest of this journey is going to be.
So, to really sharpen that question, you've got to nail down your variables. First up, the independent variable. That's the cause. It's the thing you're changing or controlling. Then you have the dependent variable. That's the effect. It's what you measure to see what happened. Getting this cause and effect relationship right is the absolute bedrock of a logical test.
Next up, you got to ask, are my variables categorical? Meaning, do they fit into neat little buckets like yes or no, cat or dog? Or are they continuous, things that exist on a spectrum like height, weight, or temperature? This distinction is absolutely fundamental for what comes next.
So why does all this matter? I mean, really. It's because getting your variables straight right at the beginning isn't just some boring textbook exercise. It is the foundation that stops you from accidentally picking a test that gives you results that are completely meaningless, or even worse, just flat out wrong.
All right, on to step 2, figuring out your data type. Now that you know your variables, let's take a closer look at the actual nature of the data you've collected for them.
So your data is generally going to fall into one of 4 levels. You've got nominal, which is just names or categories, like red or blue. Then there's ordinal, which adds a logical order, like small, medium, large. After that is interval, which has equal spacing between values. Think degrees on a thermometer. And finally, ratio. Ratio is just like interval, but it has a true, meaningful 0. Think about weight. 0 pounds literally means an absence of weight.
An even broader way to think about this is whether your data is qualitative or quantitative. Qualitative data describes qualities. It's the what. Think interview answers or descriptions. Quantitative data deals with numbers you can measure. It's the how much, like sales figures or test scores. It really boils down to the what versus the how much.
And here is the absolute bottom line for this step. This whole classification thing is not just for fun. It's a gatekeeper. Some statistical tests are built for very specific types of data, and if you try to use the wrong one, well, it's a recipe for disaster. Okay, step 3. Let's check the data. We've got our question, we know our data type. Now we need to look at its shape and make sure it plays by the rules for the test we want to use. It's time to peek under the hood.
Is your data shaped like a perfect bell curve, what we call a normal distribution? Or is it kind of lopsided and skewed to one side? Understanding the shape of your data is a huge clue that points you toward the right family of tests to use.
Think of this part like a pre-flight check. Most tests have what we call assumptions. For example, homogeneity of variance is just a fancy way of saying the groups you're comparing have a similar amount of spread in their data. And independence of observations just means that one data point isn't influencing another. Checking these rules before you start, make sure your results are actually valid.
And that brings us to step 4, selecting the test. All that prep work we just did, it was all leading up to this moment. This is the main event, where we finally pick the right tool for the job.
And you know what? It can be surprisingly simple. Look at this. If your goal way back from step 1 was to compare different groups, then you're going to be looking at tests like a t-test, ANOVA, or chi-square. But if your goal was to find relationships between variables, you'll be using tools like correlation or regression.
And this is so cool because it shows the real power of what we've done. That super clear question you worked so hard on in step 1, it didn't just give you direction, it has dramatically narrowed down your options, making this big decision pretty straightforward actually.
All right, we've made it to our final step, and it's a practical one: choosing your software. What tool are you actually going to use to run the numbers and, just as importantly, make sense of the results?
You've got a ton of options out there. There are statistical powerhouses like SPSS and R. There are tools you probably use every day, like Excel. And then there are super versatile programming languages like Python, which have amazing libraries for data analysis.
But here's the real key. Don't pick a tool just because it sounds the most powerful or the most complicated. Choose the one that actually matches your skill level. The goal here isn't to be fancy. The goal is clarity and getting it right.
Please remember this. The most advanced software on the planet is completely useless if you can't understand what it's telling you. The best tool, for you, is the one that lets you clearly and correctly tell your data story.
Because that's what this is all about, isn't it? Following these 5 steps changes you from someone who just has data into a storyteller who can actually uncover the amazing insights hidden inside. Your data has a story. The only question left is, are you ready to tell it